All right, everybody, welcome here to video number 4 or lesson number 4. So in today's lesson, we're going to talk about the properties of logarithms. A couple of things about logarithms. There's actually lots of properties of logarithms. There's just a couple of things that we're going to use in our graphing and some of our solving that's going to help us a little bit here. So some of these properties will kind of keep coming back up. In pre-calculus next year, you'll learn a lot more about these properties. Today, we're kind of just getting through the ones that we really need just for this course. So what I'm going to ask you to do here with the opening exercise is use what you already know from lesson number 3 about logarithms and try and evaluate each one. All right, so now that you've evaluated each one, either using what you know about logs or even your calculators, I'm hoping that you got an answer here of 2 for the first one. 10 to the second power is 100. Negative 1 for the second one. 1 for the third one. Then for the next 3, you should have gotten 1, 3, and 1/2. Now, the reason why these 6 examples are important is these 2 types of logarithms are so special or so common that they have special names. The first 3, the ones that have a base of 10, we call those common logs. So log base 10, these are common logarithms. So when I write like log base 10 of 100, actually I could just write log of 100. And you could use just the log button on your calculator to the left of your calculator. You don't have to use log base for this one. Log base e functions, like log base e of e, well, these are known as natural logarithms because e is a natural number, right? It comes up in consistent growth and decay, so we call that a natural logarithm. This has a button of ln, so we could say ln of e. So instead of saying log base e, we just say ln of e. Both of these are buttons right on your calculator here and here. So let's go and see if we could generalize some properties. So here are 6 examples. Log base 2 of 8 plus log base 2 of 4, and see how that relates to log base 2 of 32. So log base 2 of 8, that's 3. Log base 2 of 4, that's 2. 3 plus 2 we know is 5. Well, log base 2 of 32 is also just 5. 8 times 4 is 32. Let's try another one. Log base 5 of 5 is 2. Log base 5 of 5 is 1. 2 plus 1 is 3. Log base 5 of 125 is 3. 25 times 5 is 125. Well, log of 100, that's a common log, so this is base 10. So that's 2. 2 plus 2 is 4. Log of 10,000, again, this is a base 10 log. So that would also be 4. 100 times 100 is 10,000. So what I'm hoping you're noticing by these 3 examples, if you re-examine them, the logarithms separated by addition can be brought together by multiplying what we're evaluating. I'm multiplying the 8 and the 4 to get to this 32. I can do the same thing backwards. So if I started with log base 2 of 32, I can say what 2 numbers multiply to make 32, and I can undo it and make it a plus. So let's generalize this property. If log base b of x is added to log base b of y, then this becomes log base b of x times y. This property is not so commonly used in Algebra 2, but it might come up in some of our problems. let's use this to evaluate something that we couldn't previously evaluate yesterday without using a bunch of decimals and stuff, like number 2. So using the same property, since both of them have the same base, I can multiply this 18 and this 2. So I can rewrite this as log base 6 of 36, because 18 times 2 is 36, making this answer just simply 2. Now, if I was to evaluate those logarithms separately, which I totally can do, if I go into my calculator, go to math, go to log base, put in a base of 6 and a value 18, I'm going to get like 1.6 something. And if I do the same thing, evaluate 2 instead of 18, I'm going to get 0.38 something. If I add those two decimals together in my calculator, I'm still going to get 2, but this is able to get it without having to use my calculator. So let's take a look at another property. All right, so we can use that property we already know to derive a new one. So the same addition property, I can say, well, if I have a common log of x to the third, well, that's the same thing as the common log of x times x times x. What we just found out on the previous examples is when I multiply here, I can rewrite that as 3 separate logarithms all added together. So I have 3 common logarithms of x. Well, if I take those 3 logarithms of x and I add them up using my algebra properties, I can say log of x to the third, well, that's the same thing as 3 log of x's. So notice what happens is the exponent on the x to the third, that 3, well, that goes to just as a coefficient of the log. Let's see if that always happens. Let's try one with the base of 2. So log base 2 of y to the fifth is going to be log base 2 of y times y times y times y times y. Well, since all those y's are multiplied, I can make them all added together. So I can say log base 2 of y plus log base 2 of y, etc. Running out of room here. And there are 1, 2, 3, 4, 5 of them. So we could say log base 2 of y to the fifth power. Well, that's the same thing as 5 log base 2s of y. So we're seeing in both cases, and let me just grab a different color here so we could show it, is the exponent is coming to the front. You're going to see me do this a lot in the future lessons. I would say out of all of the properties of logarithms that we'll go over in today's lesson, this is the most important one. So let's generalize this property. The log of any base of x to a power becomes the power times log of that base of x. And again, this one is super important. Okay. Let's expand a couple logarithms. So if I take this logarithm of x to the third times y to the second, again, this is a common log. We call it a common log because there's a base of 10 here. Well, I could instantly rewrite that and say, well, that's log of x to the third plus log of y to the second. The reason why I can do that is because these two expressions are multiplied. Then I can say, well, those exponents could also go somewhere. So I can put those exponents in the front and rewrite this as 3 log of x plus 2 log of y. That's what we consider expanded form. Again, just knowing that they're equivalent, that's the big concept for this year's class. All right, like I could easily see this being a multiple choice question and saying which of the following expressions is equivalent to that. Well, if we could expand it all, that means I could bring it all together. So here's an example where all 3 logarithms are separated. Notice in this case, I'm using natural logs. ln is the same thing as log base e. So the first thing I want to do is I want to bring them all together by making all of those coefficients exponents. So I'll say the ln of x squared plus the ln of y to the 1/2 plus the ln of z to the 3rd power. I'm doing the exact opposite of what I did in 6. Now, since all three of these logarithms are added together, I can rewrite this as a big product, x squared, y to the 1/2, z to the 3rd. So notice when I'm writing it as a single logarithm, I'm trying to bring it all together. This is one single log now, where previously it was 3 separate logs. Okay, so let's use our properties of exponents to discover the last property we're going to go over here today. How else could I write log base b of x divided by y? So since y is being divided, division can be rewritten using exponents. Y to the -1, well, that's the same thing as divide by y. If you're not sure how I did that, what I did with x over y is I rewrote it as x times 1 over y, and then I said, well, 1 over y is the same thing as y to the -1. That's a thought process behind that step. Now, using this property that we've just used, we can say, well, that's log base b of x plus log base b of y to the -1. But we know that exponents become coefficients, so I could say log base b of x plus -1 log base b of y. Now this just looks funny here, right? I wouldn't write plus a -1, so I would rewrite this as log base b of x minus log base b of y. So what we can see here is we're developing a brand new property. When I divide inside of a logarithm, I can rewrite as a subtraction problem. So let's try this one more time. Log base 3 log of x minus 1/3 log of y. So again, notice it says single logarithm, so I want one logarithm in my answer. So the first thing I want to do is I want to bring those exponents back. So I'm going to say log of x to the 3rd minus log of y to the 1/3. Y to the 1/3 from the last unit we know is the same thing as the cube root of y. So I could rewrite this as one single logarithm of x to the 3rd divided by the cube root of y. So now I could expand a bunch of different expressions, like this next one. 10 would probably be the most difficult one I would ever give you. So the first thing I want to do is make it so that I have 3 separate logs. So I'd rewrite this as a natural log of the cube root of x squared plus a natural log of y squared. And then I would subtract, because this z is in the denominator, the natural log of z. Now, the cube root of x squared, again, using exponent over root, we now know that that's the exponent of 2/3. So I could even rewrite that and say, right, this is really the exponent of 2/3. Same thing. And then we could bring our exponents to the front to completely expand my log. So I have 2/3 times the natural log of x plus 2 times the natural log of y minus the natural log of z. If you're able to do this one on your own, you're in really good shape. All right, so let's play with our calculators here a little bit. So in your calculator, remember there is a log button, there is a natural log button, and new calculator people, you have a log base button. So this you're going to use log base for, right? That's, remember, underneath math. So if you type into your calculator log of 8 divided by log of 2, make sure you end your parentheses, the answer that you should get is 3. If you type in natural log of 8 divided by natural log of 2, you should also get 3. And if you type in log base 2 of 8 using log base, those of you that have it, you also get 3. So you're noticing all three of these expressions generate the same value because they're essentially doing the same thing. Now, the big concept here isn't for you to understand why they're all the same thing, just to know that they are actually equivalent to each other. Right? There's always questions on the Regents exam where it's multiple choice and it says which of the following is not equivalent to the others, right? So you should be able to see that or just know how to plug them all into your calculator correctly. Try the next one, see if you get the same three answers. All right, so we're going to get the same three answers here. So the log base 10 of 81 divided by log base 10 of 3, or common log of 81 over common log of 3, that's going to give you an answer of 4. So is natural log of 81 over natural log of 3. And so is log base 3 of 81 if you use log base. Again, these are all just calculator problems. So let's extend our property above. So this property that we're seeing, this helps the older calculator people evaluate logs, is any logarithm of any base can be evaluated by the common log of what you're evaluating divided by the common log of the base, or the natural log of what you're evaluating divided by the natural log of the base. On the bottom of the page, there's kind of a little lesson summary. So these are the three main properties you need to know about logarithms. If you know these three properties, you can evaluate any logarithm in the homework questions or pretty much any one that we're going to ask you to do for the future lessons in this chapter. So this lesson summary kind of goes over everything that we just talked about in the lesson. Hopefully this helps. All right, you'll see that there's a homework video also attached here in the same post on Google Classroom, so you can kind of try the homework as well. Make sure that you're trying the homework before you just watch the video. It's important to know, especially since you're kind of doing remote learning here, that you are getting the right answers. Okay, so make sure that you're trying it. Don't just watch the video. All right, watching the video for the notes is great, but for the homework, try the homework first, then watch the video and see if you did it right. All right, check in with me if you have problems, and I hope to see you soon.